Hello everyone, this is Jelly once again, and we are continuing with our previous project, which is the next word predictor project. And in this project, it's still the same, going to tackle the same problems of slow typing. Let's say your typing speed is very slow, especially on the computer. It's very slow, and you also have the troubles of spellings. Maybe the spellings of some words disturb you. So that's what it's going to tackle mainly. And I chose the dataset for this project, and I'm going to use the Adventures of Sherlock Holmes. This dataset, it's mainly a passage, and it contains a lot of English words which can be stored as reference to this project, since it mainly requires text, and text has words. And the factors I considered for selecting this dataset: one, it's the range of words. So mainly this dataset contains a lot of English words used in the dictionary, that's being helpful in this project. Since this project mainly will be dealing with words, predicting the next word, therefore you have to store a lot of words, which maybe there are many to satisfy the words in the dictionary. Then also the data type. This dataset has been selected because it contains text as the data type, which is highly applicable and the one needed for this project. As previously in the last video, I explained the data type which I'm going to use for this project, and I explained that I'm going to use text, and text is the one which contains words mainly and other symbols and words combined with symbols maybe and integers. So that's text, and it's the data type I'm going to use. And then also I will consider satisfaction. I first went through this passage. I saw the number of words in this passage which have been used as my safety database become available for use. The words in this passage which I chose as my dataset, they are more than enough for this project. And again, I considered the words which are in this dataset, the passage which I used, and the words which are in this passage, they are commonly used by people and also can be used to solve the spelling problems. So those are the factors I considered. And for the features in my dataset, my AI model will likely use, first of all, this passage which has been selected, it contains correct spellings. Since I'm aiming at solving the problem of spellings, this passage can be of use because all the words which are there are correctly spelled. Then also coverage of words. This passage covers a lot of words. It covers a lot of words, and those words, they are always found in the dictionary. So they are mainly, my project will be basing on English. Then also simplicity of words. The kind of words found in the dataset are in their simplest form, which will be easily understood by the users who may be in need of them. Then also relevance. This dataset, it has the language which is highly relevant to this kind of model being developed, since I'm mainly using English. Then the data type in this chosen dataset, it's mainly string, and for string stroke text, it's the data set I chose to use for my model. Then we can talk about Bayesian theorem. This is the theorem that describes the probability of an event based on prior knowledge of conditions that may be related to that event. Bayesian theorem, it's based on probability, and probability, probability refers to the chances of an event to happen. Then for naive Bayes, this is a supervised learning algorithm which is based on Bayes theorem and used for solving classification problems. In this theorem, it is mainly used in text classification that includes high dimensional training, naive Bayes classifier is one of the simple and most effective classification algorithms that help in fast machine learning models that can make quick predictions, and it also predicts based on the probability of the object. So naive Bayes, it has two words. First of all, naive means, okay, it's called naive because it assumes independent probability. Then for Bayes, it was called naive Bayes because it's based on Bayes' theorem also. And for Bayesian networks, these are probabilistic graphical models which represent a set of variables and their conditional dependencies using a directed cyclic graph. They are probabilistic because these networks are built from a probability distribution and also use probability theory for prediction and anomaly detection. So Bayesian networks, they are directed to a cyclic graph. A cyclic graph, this is where you find maybe one node connecting to another, and in that process of connecting, maybe they form something like a circle. So that's why it's directed to a cyclic graph. And for the difference between Bayesian theorem and naive Bayes. Bayesian theorem allows us to infer the probability of a particular model given observed data, whereas naive Bayes, it's a type of prediction model which assumes that all features are mutually independent. And then now we can go the difference between, okay, you can differentiate naive Bayes and Bayesian networks. For naive Bayes network, it's a restricted form of Bayesian network where you enforce the constraint that a class node should have no parents, and that the node corresponding to that attribute variables should have no edges between them. While in Bayesian network, the features are selected based on squaring functions, which mainly restrict the structure and the parameters using the data. And if you want to read more, you can use these links. For Bayesian brief network, you can visit this link, and for the type of dataset I used, for more information you can click on this link and visit the website for it. Then for naive Bayes, you can click on this link, and for the differences between naive Bayes and Bayesian theorem, you can visit this link. And for the differences between a Bayesian network and a naive Bayes classifier, you can visit this Stack Overflow link. Thank you for watching. You can subscribe to my channel for more videos. Like, comment and share.